This video will explain the counting circuit and all the 7 sections that are included in the outcome. The first section is the analog input. It uses a push button, normally open or PBNO, so when the button is pressed it reads low. This circuit uses a pull-up resistor and the 4011 NAND logic gate. The second section is the NAND gate oscillator. It adds on 3 more resistors, 2 capacitors, one of which is a 0.1 microfarad capacitor, and the other is a 10 microfarad capacitor. The circuit works by when the button is pressed, the LED creates oscillation. The next section is the decade counter. The decade counter uses a 4017 chip. This circuit has 10 green LEDs that make a 10 LED counter. I also used a BB10 LED bar graph to show an overall smoother counter. When the button is pressed, the output pins light up the LEDs that they are connected to. This circuit also has a carryout, so every 10 cycles that the LEDs make, this LED will flash. The decimal counting binary up-down counter is the next part of this project. This is an addition to the previous circuit. The circuit's power comes from its new chip, the 4510. It is a BCD chip, which means it's binary coded decimal, telling us that it counts from 0 up to 9. This circuit is a 4-digit binary counter. This chip has 4 outputs, meaning it can only count the first 4 digits in binary, which are 1, 2, 4, and 8. The next 2 sections are combined into one as they are both integrated into one circuit. The binary counting decimal decoder and the 7-segment display come together to make the final counting circuit of this project. The 4511 is responsible for decoding the binary number created by the 4510. There are 4 inputs that are meant for the 4 outputs of each number in binary. The binary number it takes from the 4510 and splits them into 7 outputs. Each output is for one of the 7 segments in a 7-segment display. The 7-segment display can either count up or down, determined by which way the switch is pressed. The final 2 steps before finishing this project were to solder all of the parts used in the final counting circuit onto a PCB or printed circuit board. The PCB is a good-looking compact display of the counting circuit and sums up all the work we've done so far. The case holds a battery that is permanently soldered down to the case. This battery is connected to the off-on slide switch. There's another slide switch that indicates whether you want the circuit to count up or down. Here are some photos of the soldering work. There you can see the battery attached to the case and the terminal blocks that are connected to the PCB.